Hello everybody. Today I should be building a successful sodium chlorate cell. And okay, so I'm just going to show off the parts of this. First off, we have the jar, which is considerably large, the sodium hydroxide, which I will fill into here, and which I will bubble gas into with this gas line and use these electrodes. Now, before we start getting into the nitty-gritty of this whole thing, I feel like I should preface what a sodium chlorate cell is. All a sodium chlorate cell is the electrolysis of a salt water under specifically sodium chloride, that kind of salt water, under inert electrodes. Now, why inert electrodes is because if you use something like steel, kind of like this spoon over here, use something like that for the positive electrode, it would corrode away at it and it would react to form metal oxides. Now, inert electrodes are like graphite and platinum. Now, I obviously don't have platinum, and I did use graphite in some other attempts. The problem is it corrodes really easily. But this time I'm using MMO electrodes, or multi-metal oxides, which are made out of rubium and osmium, if I have the names correct. And basically, they are very corrosion resistant. They don't react, super inert. As long as electricity is flowing through them, they stay strong. They are the industry standard in chemical productions via electrochemistry and stuff like that, where you need inert electrodes. It's also important to say that this is my power source. It is a 120 volt down to 12 volts. I'm gonna get the name transformer. So around 12 volts will be running into the cell over there. It should be a little bit more than enough, but it should work well. And also, I have to state this, but the salt that you're using, it should have no iodine. It messes up with the process, and it's really hard to find salts that don't have anti-caking agents, but they shouldn't be any problems with the anti-caking agents. They just have small impurities, so it shouldn't be or pose problems. So just normal cooking salt like this will do the job. Okay, so I have filled up the cell with the appropriate amount of water, and I also have over here the amount of salt needed. The maximum amount of salt I can dissolve into the water, and I think I'll add a bit more. So now it's just time to get pouring. Okay, I have all the salt over here. Now I just need to pour out the sodium hydroxide. Okay, now I am just going to add in the electrodes. Turns out that when I was using the alligator clips, they heated up very, very quickly. So I don't want anything bad happening. So I'll just use good old 5 volts. Okay, back with this. how many times have I tried this? 4 times? Okay, 4th time's the charm. Add a chlorate cell, please, please. Yes! It's working. It's hard to see, but look, it's right there. It's going to take a while for gases to come out of there, but it's going to happen eventually. Just look at that. It's working beautifully. So it has been running for maybe a couple of minutes, and it's finally starting to bubble right here. And that was probably a good time to explain the chemistry of this cell. So on the negative electrode, the titanium one, what happens is it splits the water into hydrogen and hydroxide, which kind of lowers, it heightens pH. And on the positive electrode, the MMO right there, it splits salt into chlorine and sodium. The sodium stays behind. And oh, it's like really ramping up. But as hydroxide, over a couple of hours, the pH gets high enough as to where a more energetic reaction is allowed to happen, and the positive electrode is allowed to ionize the chlorine gas and turn some of it into hyperchlorite, or CHLO. And as that heightens over a couple of hours, by the end of the day, so maybe by tomorrow, there will be enough of it as to where an even more energetic reaction can occur, where you can have 2 oxygens strapped to a chlorine, creating chlorate, which falls behind, mixes with the sodium, and produces sodium chloride. So right now it's just producing hydroxide and some chlorine, and the chlorine is being scrubbed through here, and some hydrogen gas is all that leaves, but the chlorine is being left behind and being absorbed by the sodium hydroxide. So this shouldn't start producing by tomorrow, and even then it will take a couple of days for it to all crystal out of solution, the sodium chlorate, as it is very, very soluble in water. Although the good part is this lab is all outside, so the cold breeze should kind of make the sodium hydroxide less soluble in the water. Should probably also explain that once everything is all done, I'm going to pour out the liquid into here over this coffee filter. I'll pour out the liquid a couple of times until I'm just left with the crystals. And actually, no, I'm going to put this in the refrigerator to get it all cold. And then I'm going to let it, which brings it, kind of brings it out of solution. This way, when I leave it back to room temperature, it all crystals out. Then I can pour it all out into here, and just leave the sodium chlorate right here to dry, maybe under a heat lamp, and until it all dries out, and I'll be left with pure sodium chlorate. And if it's not pure and it's filled with metals and stuff, I can always recrystallize it. After all, I have a whole lab here, and I will be giving you more updates today. So this is day 3, and I figured that I would be able to find some other wires rated for the 12 volt job, and I did. My 12 volt power supply switched out 5 volts, so it should go much faster now, in which it is. And it is hard to pick up on camera, but it kind of has a yellow hue even when the light is turned off. Hard to pick up, but maybe that's chlorine dioxide, which is a good sign that the process is going well, although that would also mean that its efficiency is quite bad. But overall, everything's good. It's pH has stayed at around, I believe, 5, so slightly acidic. And really, that's all I have to say for day 3. So just wanted to add that this lamp here was for heat because the cell was getting pretty cold, and it's optimal for the solution to be pretty warm. So and 12 volts is enough to heat up all this solution. So I'm using a heat lamp, and it's kind of warm. And also that stuff at the bottom, if you can see, there's small specks. I think that's some of the anti-caking agent. And that's all I have to say to you. I'll come back to you with more updates in the future. Okay, hello everybody. I have some quite concerning news because this is day 20 and nothing. I checked pH with this guy over here. It's perfectly normal. And I tried scraping the salt at the bottom to see if there was an issue, and it's rock hard. But it's been 20 days. Using 12 volts, 5 amps, it should have finished a long time ago. So I'm thinking that it's the salt. So I'm going to replace it with kosher salt to and hopefully that will work, because if not, and also try to find a voltage and amperage supply and get 10 amps in this cell. And if that doesn't work, well, I don't know what will, because 20 days without any notable progress is quite concerning. Okay, hello everybody. I have now my voltage supply. I have my electrodes, which they could be better, and I have my cell filled with the kosher salt. Now I'm just gonna plug in everything. Okay, everybody, I'm back. I have the sodium hydroxide, the salt added in with a smaller layer at the bottom. The electrodes are there, and I have the alligator clips. So I'm now going to turn on this right here. And current 5 amps. Working a lot better. Let's see what I can do to the volts. Oh, it's increasing the amps. Okay, that's the highest on the amps I can go. Oh, it's not. Okay, it's locked. Ah, it's not locked. That's how high I can get the amps with it staying in. It is electrolyzing really fast, and it's bubbling up quite a lot faster. This is quite a large improvement. Just gonna add the lamp right there so you can see everything better. It's very white, the top, and everything is working quite well. So here's the lab light fixture outside. I feel like I should show you all of these things, but so just felt I should show you around the lab so you get a feeling of things. And probably just going to turn this off for now so I can show it to so I can boot it back up and show it to my dad. Okay, so everything's in order. It's doing perfectly fine. I think the reason it can't go up to 5 amps is because of resistance or something like that. It's vibrating and fans blowing, and it's pretty cool. It's not overheating. It's bubbling quite nicely, and Here, let me turn on that lamp. There, so we can get a better look of the electrolysis. Going quite well. Okay, so for this power supply, when I had to plug it in, I had to leave its ground out, and without the ground, it could short circuit and die, and I really don't want that. So I made this makeshift ground wire with a spoon. I'm going to connect it into the dirt. Okay, I am back again. The amps have increased for unforeseen reasons. It's pretty cool. This fan is just blowing on me. It's quite hot outside. The internal fan is going. The ground line is doing its job. It's bubbling better than ever. And also, before anything happens, I should probably say that when I was messing around with the lighter, what happened is some of the combustion went backwards into through this tube and combusted over there. This lid fell out and it kind of launched up like a rocket, and these the tips of the electrodes scraped the side of the wall, hit the ceiling and fell back down. But everything is doing fine. I think the reason the amps going down, I think the reason they increased was because of lower resistance for some reason that I do not know, but everything is looking good. Cell's looking good. Monitor's looking good. Bubbling is looking good. And ground is looking good. Okay, well, I don't know if this is me, or do you see those tiny, look like rainbow crystals? Call me crazy, but I think that might be some of the sodium chlorate. Kinda looks it. They look like tiny little crystals. So I think that might be a good sign. In a couple of days, I should get a hot plate. This way I can heat this up to the optimal temperature, the water, so it can be at optimal efficiency. And over the days, I'll be checking its pH. Hello everybody, I'm back again, and to increase efficiency for the cell, I will be adding in some heat. As you can see, I have a hot plate which has a stir bar, which I will be showing to you in just a second. Just for a demonstration, I'm using a stir bar. And the heat actually works pretty good. And now, I'm also going on a vacation while this guy runs, so I'm intending to put extra salt in it, and just so it can last the 3-day vacation, and there's like 2 half days, so 4-day vacation. And to keep from excess heat from building up, I'll be using this fan, and heat will still build up, so I'll have it at the lowest setting of heat. So I'll be adding just in a bit of extra salt. Stuff's quite difficult to pour. It kind of clumps together. And that should last me for the next couple of days. Drop in the stir bar. Get to stirring. Like, turn that on, get to stirring. Yeah, I need to put on lower power for it to spin. Get it to move back. Move back. There we go, and just like that. And it's gonna be out of control. So I have my pliers here. I want to pull that stir bar out. You see it? Yeah, can't. Actually going pretty fast. The camera just can't catch it fully. I will put in the electrodes and then turn on the power supply and add the heat. Okay, I have everything set up. Now I'm just gonna dial up the power a bit. There it is. Bubbling as normal. Now I'm just gonna okay, fan is blowing, and I'll come back to you in a few minutes with an update. I'll come back to you, and we'll just leave it like this, and everything should be. Let me just adjust that. And yeah, there we go. Everything will just be good. Okay, it's the next day, and everything is going quite well, and heating up the cell quite well. I actually had the fan on, so heat didn't build up, although I kind of carried away a bit too much heat, so I think I'll just put it on the lowest setting, and instead of focusing the heat on here, I'll focus it down here so this doesn't burn out or anything. But electrolyzing pretty nice, although I don't know, there might be less bubbles. I can't quite tell, and my lamp is dead, but might be less bubbles, might be more. I don't know. And I feel like the water level has gone down significantly, so that's all the updates. And ooh, yeah, hot plate is doing its job. Everything is good. We're all jolly and happy. Okay, it is my day back. Everything is good. The cell's working perfectly fine, and I think that right there is the chlorate. Sure, it's mixed with some rust and it's in a very tiny layer, but how can you expect there to be a high layer when chlorate's solubility is based on temperature, and I have this at quite high temperatures. So far everything's going good. Yeah, I'm gonna go get a sample of this and put it in the freezer and check how much chlorate crystallizes out, if any. I had forgotten to wear my lab coat, and this stuff has an extreme pH. I checked the pH, and I'm pretty sure the reading was wrong, but I think it said like 21 or like a pH of 12. Maybe I was reading it from the wrong way. Yeah. Yeah, I think I had a pH of 12, and this stuff barely any got on in it. It bleached my clothes because this solution has a far higher pH than than bleach, so it really messes up any cloth or fabric that touches. So please go through the liberties and get a lab coat like me, and always remember to wear one, and never forget to wear one. Okay, so I have the sample quite a bit later, and look at those crystals. I'm pretty sure that's not ice. Sure don't look like ice. I believe that's sodium chlorate. Okay, so I looked at the sample and I believe that it was mostly ice in there, so I did another test. This one is a definite test. So I soaked this paper in the solution of bleach, and what happens is it all evaporated away, the bleach and all other variables, which means that if there is any sodium chlorate, that should be all that's in there, which means if this burns really well due to sodium chlorate being an oxidizer, then there is a good amount of sodium chlorate. So now I'm going to burn it. First, I just have to find something to prop it up on. There we go. See that? Burns so much better. And that's because there is some sodium chlorate in the water, and I assume a substantial amount, so this pretty much proves that there is sodium chlorate. Okay, so once again, it is a couple of days later, and the salt has once again significantly dropped. I will stir it around, so make sure it doesn't bunch up, and I'll leave the day mark on how much this specific cell has been running up there, and how much it's been running with the hot plate, how much and how many days since I added that big chunk of salt, so you can see the progress of the salt consumption. So yeah, that's really all, just a short update. Oh, and I forgot to mention, but the salt creep has gotten quite a lot worse, and its yellow color is because of rust, as water kind of boils off a tiny bit or splashes on the ceiling because of the bubbling, and then it just evaporates and condenses over here, and when it condenses it turns into a liquid, rusts it over, absorbs some of the rust, and then drops back into the solution, and it's rusted the top quite much. But just gonna look at that. It's also affecting that piece over there, but that's all good, and it's starting to creep around the sides. Okay, this is burn test number 2. Woo! That is, wow. The amount of sodium chlorate that must have been in there. That I did, and it just carried all the way. Oh, did you hear the way that it was sizzling? Hear that? That is just crazy. Okay, so a couple days later, and chlorate has been crystallizing out of solution like crazy. Can you see the crystals? It's quite hard to see, but they are right there. And on the electrodes, there are quite a lot of crystals. So that's just really, really good. Okay, I think it's a day after the last video, and it's barely slowed. It slowed down a lot. It's almost completely clear the solution. I didn't even notice it was on until I saw it, and there's only 2 amps because the electrodes are completely filled with chlorate crystals, and I mean completely filled. So there's barely any bubbling, but you can see quite a lot of chlorate at the bottom, and also quite a lot of salt creep. I'll extract the chlorate tomorrow. Okay, everybody, I'm quite excited. This is extraction day, and I've kept away the fan so it can heat up properly, and I'm just gonna wait here for all of this to kind of dissolve away into the water. Why everything's looking so red is kind of rust, but that shouldn't matter because I'm using this for pyrotechnic reasons, and the rust should actually boost up the power of my rocket motors. It's just the cell is not looking good. I definitely have to replace this lid with a plastic one on my next run, but basically there's a bunch of chlorate on the electrodes. So basic idea is to kind of dissolve it away, although probably have to fill it up with new water, so I'm gonna go do that. Oh, and the process for extraction of chlorate is basically I would freeze the solution and pour it over a coffee filter because the chlorate would all crystallize out, although this plan did not work, as you'll see later. Okay, it's maybe like 1 to 2 days later, and then this fridge will not budge. This fridge is so difficult. It's on its coldest setting, and I think it's 1 to 2 days later, and as you can see, there's chlorate crystals all along the bottom. Let me just clear that up right there, clear the frost so you can see crystals all along the bottom. Some big crystals right there. Yeah. Okay, so the plan to freeze the cell did not really work. So instead what I'm gonna do is I'm gonna boil off the water to leave behind the sodium chlorate in the hot plate, and I'll use a thermometer to constantly check in on if it's at 212 degrees Fahrenheit. This way it doesn't reach the temperature in which sodium chlorate decomposes, where then all my stuff will just turn into oxygen gas, which really sucks. So I'm gonna cut to the next clip showing you that. Okay, everybody, I poured out all of the solution into here, and now I'm going to boil everything away because last method didn't work, and I'll come back to you once everything's done. The hot plate was taking quite a while, so I decided to use a open flame, and I am aware that sodium chlorate decomposes at 300 degrees Celsius, 500 and I think 12 degrees Fahrenheit, but I did test it with a charred piece of wood, and when I put it over here, if it was at a high enough temperature to decompose sodium chlorate, all of this smoke would be oxygen and would cause the ember to really glow up, but it only glowed up when I blowed on it like really hard. So it's at a correct temperature, and I've been doing that for a couple of minutes, and I've noticed water level has gone down. I also know that there's a significant amount of sodium chlorate in solution, because whenever it drips down, the fire burns super strong. So I'll come back to you once this gets to a later stage of boiling. So see ya. Okay, it's reached a point where sodium chlorate cannot fully be held in solution, so it's kind of forming a crust on top, which is quite interesting. The chlorate is all dry. I just need to scrape everything from the sides. Are you guys ready to see the chlorate? That is quite a lot. I'm actually gonna get my scale. Kilograms. And $929 grams. Now I've mixed some sugar with the sodium chlorate, so I'm gonna burn it and test to see if it works. Oh, leave! Okay, so you have just watched me turn and learned how to turn salt into rocket fuel. So we've done several tests on it. We've learned that this is quite high quality. We've learned how to do it, and also safety disclaimer right here. Sodium chlorate, always store it in just its chlorate form like this, and never as rocket fuel, because it's really sensitive, like really friction sensitive. So if you store it in a rocket fuel form, your chances of your house burning down, or in my case shed, is not high but not low. So please, the day that you are going to use sodium chlorate as rocket fuel is the day that you make the rocket fuel, where you add in the sugar and everything. But anyways, I hope you guys learned something. Stay curious. Remember to have fun. Fly safe.